Alright, number 48. Oops. We want to find the dimensions of the solid giving maximum volume, given that surface area is 8. So surface area is 8. I've got a closed rectangular box with a square base. So it's coming up here like this. Okay, that's a terrible drawing of it because all the backside ones are dotted. But you get the idea. So the square base, x and x, and the height is h. So we've got the volume is x squared times h. And I want to find the derivative of volume to see what makes it a maximum, what x makes it a maximum. Well, I've got x's and h's, so let's try to solve one for the other. So if I've got surface area is 2x squared, right, top and bottom, plus 4 sides, 4x h's. So the surface area would be, would be 8, which is 2x squared plus 4x times h. So that means 8 minus 2x squared is 4xh. I'm solving for h. So h is 8 minus 2x squared all over 4x. And if I divide top and bottom by 2, I get h is 4 minus x squared over 2x. Alright, so that gives me over here volume is x squared times 4 minus x squared over 2x. So if I go ahead and cancel the x's, one of those and one of those, I get 1/2 times 4x minus x cubed. Okay, makes sense? Now I want to find the maximum value for x, so that's v prime, or dv dx. It's going to be, well, let's go ahead and write this, maybe make it even easier for you guys. If I write this as 2x minus 1/2 x cubed. So the derivative would be 2 minus 3/2 x squared. And I want to set that equal to 0 to find the critical points. So that means 2 equals 3/2 x squared. So that means 4/3 equals x squared. So that means x is plus or minus the square root of 4/3, which is plus or minus 2 over the square root of 3. Now, I'm not worrying about the negative result because x is a distance, so it's just going to be 2 over the square root of 3. That's an interesting number for this, but we'll go with it. And I'm going to look at 2 over square root of 3, which I checked is about 1.15. So if I plug a number below, smaller than that in to the derivative, like 1, 2 minus 1.5 is positive. V prime is positive. A number bigger than it, like 2. 2 squared is 4. 3 times 4 is 12, 6, so negative. So it's increasing, decreasing. So that tells me that, so x equals 2 over the square root of 3 is a maximum. And it said find the dimensions, so now I got to figure out what h is. Well, according to this formula right here, I get h must be 4 minus 2 over square root of 3 squared all over 2 times 2 over square root of 3. So that gives me 4 minus 4/3 over 4 over the square root of 3. So that's going to give me, let's see, this is what, 12/3? So 12 minus 4 is 8/3 over 4 over square root of 3, which is 8 square root of 3 divided by 12. Or if I divide those by 4, I get 2 square root of 3 over 3. So there's h. Okay, so here's my x. I said is a max, I should say gives max volume. So the dimensions for my box are 2 over the square root of 3 and 2 square root of 3 over 3. Kind of crazy numbers, but there's my dimensions to give me a surface area of 8 and a maximum volume.